Hello everyone and welcome to the Python programming series part 14. This is Ram Prasad Pujari. In this session we'll continue our discussion on performance matrix used for classification algorithm. In the previous session we discussed about confusion matrix, four important measures called as true positive, true negative, false positive and false negative, and using these four measures we calculated accuracy score. We also understood that accuracy score is misleading in some of the cases, and you need to go for other measures like precision, recall. So this is what we understood in the last session. In today's session, we will look into these three important measures, and we'll try to understand that how these are calculated and how this will be helpful when accuracy score is misleading. So we are focusing on precision, recall and F1 score. So let us look at the first performance metric, that is precision. The mathematical definition for precision is shown here. So precision equal to true positive divided by true positive plus false positive. So this is the mathematical definition of it. And in the last session we understood these terminologies like true positive, false positive, etc. True positive refers to a case where actual label and the predicted label both are positive. That means when model correctly predicts the case as positive, and that is called true positive. False positive when model wrongly classifies or predicts as positive but the true label is negative. Now the precision value depends on false positive cases. So as false positive cases increase, then the precision will become less and less. So we need to make sure that number of false positive cases are minimized, because false positive is one kind of error. So in order to understand this, why reducing false positive is important and how we can increase precision, how precision helps us knowing about false positive cases. Now in order to understand false positive, we'll take, let us say, we have a machine learning model which is a medical diagnostic model which can predict whether the person has a disease or not. So let's take this example. So there is a person who is not sick, that means the true label is negative, but model predicts the person is sick. That means the predicted label is positive. So then it is called as false positive. So this person does not have the disease, but model says, he is a positive case, he has the disease. So that is false positive case. Now in this case, in medical diagnostic, with this predicting whether the person has a disease or not, which is a binary case, and negative indicate person is not sick and the positive label indicates person is sick. Now what happens if more false positive cases are produced by the model? So in that case, the people who do not have any disease, so they will be given a kind of a medication by the doctor thinking that they have the disease, and this could lead to some kind of anxiety in the people. So we need to minimize the number of false positive cases, and precision will help knowing about the false positive cases, because the precision depends on false positive cases. So when precision becomes very crucial, so we understood that when false positive cases are more severe, then precision becomes more crucial, because precision value depends on false positive cases. So as false positive cases increase, the precision gets lower and lower. So when we design a model, we need to make sure that number of false positive cases are minimized in order to get a higher precision. So let us take two different cases to understand how this mathematical equation for precision works. So in the first case, I will assume that number of true positive cases are 10, false positive cases are 2, and I will use the mathematical definition which we saw earlier. So we get 10 by 10 plus 2, and that's equal to 0.83 or 83%. Now what happens when number of false positive cases are 0 or nil? So when you use the same mathematical definition, so we get precision as 1.0, which is 100%. So it means that all the positive cases predicted by the model are correct. So precision 1.0 indicates that all the positive cases predicted by the model are correct. So there is no false positive. A model does not predict any wrong positive cases. So this is what we understand. So higher values of precision indicate better model performance. So this is about precision. So we'll move on to the next metric, which is recall. So let us look at the second metric, that is recall. I have shown the mathematical definition for recall, and this is similar to precision, except that here we capture false negatives in place of false positive. If you look at the denominator of this, we have true positive plus false negative. So now we know that false negative case is one when actual label is positive but model wrongly predicts as negative. So if you add true positive and false negative cases, so you get the total number of actual positive cases, and out of them how many are correctly classified as positive by the model. This is what a recall captures. So now let's try to understand the consequences of having more number of false negatives. So we'll take this particular example. Let's assume that we have developed a medical diagnostic machine learning model to predict whether the person has a disease or not. So having a disease, the label will be positive, and the person does not have the disease means the label is negative. So let us look at this particular person. He is a sick person. True label is positive, but the machine learning model predicts that the person is not sick. Means the predicted label is negative in this case, and so this particular scenario or case is called false negative case. Now in the previous case we discussed about false positive. That is also one type of error, and so this is also another error, and we need to minimize false negative. And minimizing false negative is much more important when compared to false positive cases. Now because we are labeling a patient who has a disease as not having any disease, which has a very serious consequences on his health. So we need to make sure that the number of false negative cases are almost zero. So even if model accepts some false positive cases, that will be fine. Of course we need to minimize false positive cases, but number of false negative cases need to be always minimized to zero, because this is very, very important. So we need to minimize the false negative cases in order to get a higher recall value. So we take two examples, two cases to understand how this is working. We have seen the mathematical definition previously in the previous slide. So first case, when true positive is 10 and false negative 2, we use the mathematical definition and we get recall as 0.83, which is 83%. And similarly, the second case, when we assume that there are no false negative cases are 0, and when we apply this over here in the mathematical definition, then you get recall as 1.0, means 100%. So it clearly indicates that the recall value depends on the number of false negative cases. So higher value of recall indicates the better model performance. So we need to make sure that number of false negative cases are minimum. Now, if you want to minimize both false positives and false negatives, then F1 score can be used, because if you look at the mathematical equation for this, so this comprises of precision and recall. So it provides a balance between precision and recall, and mainly when you have an imbalanced data set, when one of the classes is more prevalent than the other one, then also you can go for F1 score. Accuracy score may be misleading in this case, but F1 score will be better. So therefore these three metrics are very, very important. Now, when a model generates more false positive cases, then precision is preferred, and when model produces more false negative cases, then recall can be used. Otherwise, if you want to minimize both, then F1 score also can be used. So next, look at the demonstration side. I'll be using Jupyter Lab for this exercise. I'm using Jupyter Lab for this exercise. As you can see, the code is already written in the notebook, and these are the three important performance metrics that I'm going to explain you. And you need a sklearn library, and make sure that you have installed this. Now, for this coding, you can make use of any other Python IDE. You can also use cloud-based environment, which is Google Colab, or any other desktop-based Python environment also can be used here. So I need 4 functions here. One is the precision score, recall score, F1 score, and also confusion matrix, because from confusion matrix I can extract those 4 components, which are true positive, true negative, false positive, and false negative. In the last session I showed you how to display confusion matrix, but in this particular video we will not focus on that. I am importing confusion matrix because I want to extract those 4 components so that I can cross check my precision, recall, and F1 score using a formula. So I need just these 4 functions, and so they can be imported from metrics module of sklearn. So here I have already assumed that these are my actual labels and predicted labels. Actual labels are nothing but the true labels or the true output variables, and predicted labels are the one which are predicted by the model corresponding to each of these true labels. You can see that in some cases there is a variation, there's a misclassification here. So that clearly indicates that there are false negative and false positive cases. First thing I'm going to do is I will obtain the confusion matrix here. So this is the code that you use. Confusion matrix is the function we have already imported from sklearn matrix. So these are the input arguments that you have to supply. So you get a confusion matrix, and I have named as a variable CM. And from this confusion matrix you can extract these 4 components. So I'm just printing that components here. True negatives 8, false positives 2, false negatives 3, and true positives 7. So next I will compute these 3 performance metrics. Precision, this is the mathematical equation for that, and I will use the function precision score to obtain this. And again you supply the same input variables, so then you can print it as percentage with 1 decimal point, and you get it as 77.8%. So you can calculate, you can verify whether this is correct. So this is how you compute precision score, just a function called precision score to be used here. So once you compute precision score, next recall is the next performance metrics. So this is the formula that we have seen earlier. True positive divided by true positive plus false negatives. Again, this is the function, we have already imported it. I am using this function here. So then I can supply these input variables, and then I can display as percentage with 1 decimal point. So you get it as 70%. Now this precision and recall, precision 77.8%. So what does it indicate? So it indicates that among all the positive predicted cases, 77.8% of them are correctly classified or correctly predicted. So that means from, so there may be more number of predicted cases. Out of them, 77.8% of them only are correct. And similarly, when it comes to recall score is 70%. It indicates that model correctly identifies 70% of all actual positive cases or 70% of all true positive cases. So the number of true positive cases are 10, and out of them 7 have been correctly classified as positive by the model. So this is what recall score indicates. So once you find precision and recall precision, we get around 77.8%. So then recall is 70%. From this I can find out F1 score. So this is the formula, but I will use the function called F1 score, which I have already imported, and I can supply this input variables called actual labels and predicted labels, and that will give me F1 score of 73.7%. So this is how you can calculate performance matrix for classification algorithm. With this we can wind up performance matrix used for classification algorithm. Of course, there are two more metrics to be discussed, and that is AUC and ROC. So that we will discuss when we discuss about machine learning algorithms. So here I will wind up, and the next video will be on linear regression model. We are going to start discussing about the machine learning algorithms. Thank you so much.